Q5175. For internal cooling, reciprocating aircraft engines are especially dependent on A. A properly functioning cowl flap augmenter. B. The circulation of lubricating oil. C. The proper freon/compressor output ratio. The correct answer is B. For internal cooling, reciprocating aircraft engines are especially dependent on the circulation of lubricating oil. Lubricating oil not only provides lubrication for the moving parts of the engine, but also plays a crucial role in cooling various components. The lubricating oil absorbs heat from the engine components and carries it away, helping to maintain optimal operating temperatures. The oil circulates through passages and channels within the engine, absorbing heat from areas such as the cylinders, pistons, and bearings, and then dissipating that heat through an oil cooler before returning to the engine. Proper lubrication and oil circulation are essential to ensure adequate cooling of the engine and prevent excessive heat buildup that can lead to engine damage or failure. 5271. A detuning of engine crankshaft counterweights is a source of overstress that may be caused by A. Rapid opening and closing of the throttle. B. Carburetor ice forming on the throttle valve. C. Operating with an excessively rich fuel/air mixture. The correct answer is A. A detuning of engine crankshaft counterweights can be a source of overstress that may be caused by the rapid opening and closing of the throttle. The counterweights on the crankshaft are designed to balance the reciprocating forces generated by the pistons and connecting rods during the engine's operation. When the throttle is rapidly opened and closed, it can result in sudden changes in engine speed and load. These abrupt changes in forces can cause the crankshaft counterweights to experience excessive stress, leading to potential damage or failure. 5607. An abnormally high engine oil temperature indication may be caused by A. A defective bearing. B. The oil level being too low. C. Operating with an excessively rich mixture. The correct answer is B. An abnormally high engine oil temperature indication can be caused by the oil level being too low. Engine oil plays a crucial role in lubricating and cooling various components of the engine, including bearings, pistons, and cylinder walls. It helps reduce friction and carry away heat from these components. When the oil level is too low, there may not be enough oil to effectively lubricate and cool the engine. As a result, the remaining oil can become overworked and overwhelmed by the heat generated during engine operation, leading to an increase in oil temperature. 5183. Which statement best describes the operating principle of a constant speed propeller? A. As throttle setting is changed by the pilot, the propeller governor causes pitch angle of the propeller blades to remain unchanged. B. A high blade angle or increased pitch reduces the propeller drag and allows more engine power for takeoffs. C. The propeller control regulates the engine RPM and in turn the propeller RPM. The correct answer is C. The statement that best describes the operating principle of a constant speed propeller is that the propeller control regulates the engine RPM and, in turn, the propeller RPM. A constant speed propeller is designed to maintain a constant rotational speed, RPM, regardless of changes in engine power or aircraft speed. The propeller control, also known as the propeller governor, adjusts the pitch angle of the propeller blades to maintain a desired RPM. When the engine power is increased, the propeller control will adjust the blade pitch to increase the propeller drag, preventing the RPM from increasing beyond the desired setting. Similarly, when the engine power is reduced, the propeller control will decrease the blade pitch to maintain the RPM. 5184. In aircraft equipped with constant speed propellers and normally aspirated engines, which procedure should be used to avoid placing undue stress on the engine components? When power is being A. Decreased, reduce the RPM before reducing the manifold pressure. B. Increased, increase the RPM before increasing the manifold pressure. C. Increased or decreased, The RPM should be adjusted before the manifold pressure. The correct answer is B. Increasing RPM prior to increasing manifold pressure is the power change process for a constant speed propeller. When decreasing power, reduce manifold pressure before reducing RPM. This will help prevent putting the engine's components under excessive stress.